Hey guys, so today we're going to talk about the first derivative test analytically. And what I mean by that is instead of last notes, which we did graphically, looking at graphs, we're going to be using basically just a function and figuring out where those maxes and mins are, relative maxes and mins, and where f of x is increasing and decreasing, and any other specific points, critical numbers, absolute max and min, etc. So today we're going to actually have ones with graphs, just so you guys can kind of refer to them and see what's going on, but in a general sense, you'll have to be able to do this without a graph. Okay, so again, that first derivative test we used to prove or show those relative maxes and mins, right? So if f prime changed from negative to positive, it was a relative min, and if f prime changed from positive to negative, it was a relative max. Okay, so, and they must be tested, and that's what we're going to be doing. And don't forget stuff like this. F of x increasing, that means f prime is positive. F of x decreasing, f prime is negative. Okay, so here are the steps we're going to be using. We're going to find those critical numbers, set up a sign chart, and apply the first derivative test to justify our relative extrema, okay, aka max and min. So I'm going to show you these steps below, but you could always refer back to this steps 1 through 4 to see what we're doing. Okay, so first thing here, let's take a look at, again, I told you I'm giving you the graph. In a general sense, you're just going to get this, okay? And remember this closed interval here, okay, from -4 to 2. That just tells us also that by the extreme value theorem, extreme value theorem, that guarantees that there's an absolute max and min on this graph. So that's good to know for part D. We're going to be finding them absolute max and min. So finding critical numbers, remember critical numbers are where f prime is equal to 0 or it's undefined. Okay, and if we look at our graph, we can already kind of predict what these are going to be. Again, we're not going to typically have the graph, but we can just look at it visually for right now. So here's f of x in blue. So we have f of x. When is f prime equal to 0? That would be those horizontal tangents. And we notice that matches up, as we expected, with our x-intercepts for f prime. Okay, so this is where f prime is equal to 0 at those points there. And then don't forget, we're talking about increasing f of x. That means f prime is above the x-axis. Increasing f of x, that means f prime is above the x-axis. And similarly, I'll do in blue here, f of x is decreasing. That means f prime is below the x-axis. Okay, so those are all our pieces there. Let's find those critical numbers analytically, aka using algebra. So we want to know where f prime is equal to 0. So we're going to set up what is f prime of x. We're going to use that power rule there, 6x squared plus 6x minus 12. Just take that derivative, okay? We want to know when is this equal to 0. So you'll notice this kind of looks like an old algebra problem here. We're going to factor out a 6. That factors to x plus 2. X minus 1. Okay, and the 6 you could technically divide out on both sides if you want. These are the relevant features here. What is x equal to? -2 and +1. We set each parenthesis equal to 0. Okay, so those are our critical numbers. So critical numbers are when f of x is set to 0 here. -2, +1. Now notice, it also says what are the critical points. Okay, critical points would just mean take these critical numbers and plug them back in. Okay, so aka you would find what's f of -2 and what's f of 1. Okay, I'll save you guys the time from plugging it in. F of -2 is 24 and f of 1 is -3. So your critical numbers, critical points would be -2, 24 and 1, -3. Those would be the points on the graph. Okay, so now we're going to take those two values and we're going to classify them as a relative max, a relative min, or neither. Okay, so if you guys look, you probably can tell from your graph, at -2 we have a maximum relative max, and at 1 we're going to have that relative min. But what if I didn't give you the graph? Okay, so you were just looking at this is information you had. What if you didn't have a graph? So what we're going to do is do something called the sign chart. Okay, and we're going to set this up. We're going to say this is f prime, this is f. We're going to start at -4 because remember our interval is -4 to 2. So -4, and then we're going to put any of our critical numbers. So -2, 1, and finally 2. Okay, again, I used right here that -4 to 2, and then I included both of my critical numbers, -2 and 1. All right, so what we're going to do at this step is we are going to be plugging in and just figuring out if f prime is positive or negative on these intervals. We know it's 0 at these 2 points, so we want to know what's happening in between. Okay, so from -4 to -2, you guys are going to refer to basically right here, that derivative, and we're just going to plug in something between -4 and -2. So if we plug in -3, you would get 6 times a negative times a negative, which is a positive. So notice I'm not actually like spending time plugging in -3. I'm just figuring out if it's going to be negative or positive. So again, plug in to right here. So let's try another one. Between -2 and 1, you could pick 0. So 6 times positive times a negative. If I'm plugging in x equals 0, that would give me a negative. And then between 1 and 2, if you plugged in like 1.5, okay, 1.5, you would do 6. This would be a positive. So 6 times a positive, and 1.5 minus 1 would be a positive. So positive times a positive times a positive is a positive. All right, so if f prime is positive between -4 and 2, that means f is increasing. And if it's negative, that means I'm decreasing. If it's positive, that means I'm increasing. So without even seeing a graph, you guys can see how this kind of mimics the picture above for f. Okay, and this is going to help us figure out that relative maxes and mins, because at -2, I changed from f prime positive to f prime negative, so this is going to be a relative max. And you can kind of see in the shape of this. Okay, this one you can kind of see in the shape of it, negative to positive, we're going to have a relative min at x equals 1. Okay, and we're going to use that same justification we did yesterday, or in the last notes. So let's write those down here, guys. We have a relative max at x equals -2, since, or because, f prime changes from f prime positive to f prime negative, f prime greater than 0 to f prime less than 0. Okay, on the AP test, you do need to write it in this way, but you could also say f prime is positive to f prime negative. Okay, don't put plus or minus, but you could write the words positive and negative instead of the inequality. So we have a relative max at x equals -2, and then we also want to classify our other critical number. We had a relative min at x equals 1, since what happened there, guys? F prime changes from f prime negative, and then it changed to f prime positive. Slope changed from negative to positive on our f graph here. Okay, and this makes sense to us. I hope you guys look at your picture and you notice this is a maximum, this is a relative min, and relative max, so that makes sense to us that that's what happened in our sign chart. Okay, so to finish up this one here, okay, we're going to talk about when is f of x increasing. Okay, you can actually, so now we're pretending again, pretend you don't have that graph, okay, but you have this information right here. You know that f of x is increasing where f prime is positive, so you would just simply say f of x is increasing on, so from -4 to -2, union 1 to 2, why? Because f prime was positive, or f prime was greater than 0. And we got that straight from our sign chart there. So again, you're going to have to pretend this isn't there. In the future, we're not going to have that, but it is nice right now to refer to. So let's take a look then, if you guys are ready. Part D, we're talking about absolute max and absolute min. Or remember, we can just call those max and min, and absolute is implied. Okay, show your analysis. If we're going to show our analysis here, what you guys are going to end up doing is we're going to evaluate f of x at the end points and at the critical numbers. Okay, so we're going to make a little table here. So we're going to evaluate f of x. We're going to do x and f of x, basically a little xy table. And we're going to figure out what's happening at, so any of these, I kind of usually just take them, if you did this correctly, it should be these guys. Any of the endpoints and critical numbers. So endpoints -4 and 2, and then in between we have our -2 and 1, which were our critical numbers. So basically those are the 4 numbers I'm analyzing, because those are the 4 possibilities for our absolute max or absolute min. Either they're a relative extrema or they're an endpoint. So what you're going to do is we're going to actually go back up to f of x. I'll highlight this in that peach color here. You're going to go right here, and we're just plugging into the regular old f of x. We're not plugging into the derivative. We're just figuring out what is f of negative 4, what is f of negative 2, f of 1, and f of 2. Those are the 4 values we're finding out. So you plug those in. I'll save you guys the time here in terms of the video. If you plug in negative 4, you end up getting negative 28. F of negative 2, we already found that one, that's 24. We found that as our critical point. F of 1 was negative 3, and f of 2 is 8. Okay, so again, you could plug those into the original. And what you're looking for is the smallest. There it is. Smallest, this would be your absolute minimum, and your biggest. And that biggest number, again, function value, you're looking at these numbers. The biggest value there is 24. So this would be your max. Okay, so how would we write this? We just showed our analysis, so we don't have to write a justification, but we want to find the absolute max and min, aka the function values. So you would say there's a max of 24 at x equals negative 2, right? That was in blue there. And there is a min of negative 28 at x equals negative 4. Okay, now you could say that word absolute in front of it. It actually doesn't matter, because if you say just max or min, you imply absolute. If you don't say relative when you mean to, that's going to be an issue. So make sure you're careful with that. Okay, and when you're ready, we're going to try one more example here. Number 2, we'll save number 3 for class. So take a look at number 2, and let's try that process again. So I gave you this graph. I'm going to encourage you to not look at it too much and think, what if I didn't have the graph? Because that's what's going to be happening here. Okay, so first thing we want to do is find the critical numbers. Critical numbers are when h prime is equal to 0, or when it's undefined, when h prime is undefined. So when is h prime of x equal to 0? Well, h prime of x is 12x cubed minus 18x squared plus 0, right? Derivative of a constant is 0. So we set it equal to 0. We can factor out 6x squared. Okay, and when we factor out 6x squared, we end up getting, this gives us x equals 0, and this gets us x equals 3 halves. Okay, 3 over 2, 1.5. Notice that it says critical numbers, so I'm actually done. I don't have to find the critical points. So 0 and 3 halves. Okay, now the important part of this example, and the reason I'm showing you it, is because not every critical number is necessarily a relative max or min. Okay, so what we're going to do now is try out that sign chart and kind of see what's happening here. So sign chart, and remember, what do we put in that sign chart? It's h prime and h. We do the end points. Notice there was nothing given to us. That means we're just going from negative infinity up to infinity. Okay, so from negative infinity, what are the numbers we include in between? 0 and 3 halves. We include those critical numbers. Okay, so let's figure out what we're doing here. Remember, you're plugging in to, I'll highlight in yellow here, the factor derivative. You can plug into the derivative. I usually think when it's factored, it's a little easier to see. Okay, and you're wondering if it's positive or negative. We don't need a value. We just need negative or positive. So pick something between negative infinity and 0, you know, negative 10 or something. If I plug in negative 10, this would be 6 times a positive, right? Something squared is positive, times 2 times negative 10 minus 3. That would be a negative. So positive times a negative is a negative. Okay, how about something between 0 and 3 halves? Maybe x equals 1. Well, x equals 1 would be 6 times 1 squared, 2 times 1 minus 3. That would be 6 times a positive times a negative, which gives me another negative. So notice it doesn't have to alternate. Okay, and last but not least, what if I plug in something between 3 halves and infinity? You know, you could plug in positive 25. That'd be 6 times a positive, which is a positive. Okay, so this one is slightly different, again, because we notice that we have decreasing. H of x is going to be decreasing and decreasing and then increasing. So here you'll notice you kind of have that swoop, and specifically it's not even that, it's the fact that we went negative to positive in h prime. So this is going to be a relative min. Okay, versus right here, what happened? We went negative to negative. That's going to be neither a max or a min. And I want you guys actually, since we have the picture, let's utilize it. What happened here? it's still a horizontal tangent, right? Because still the derivative was 0. So you guys see it right here. But did we have a max or min here? No, it actually just turns around. It's decreasing, 0, decreasing. Okay, and right here, notice it goes below the x-axis. It hits 0, but it goes below the x-axis again, meaning f prime is negative, and over here, f prime is still negative. That's why we don't have a max or min here, because f prime doesn't change signs. Okay, so let's classify. And remember, we have to do each one. So we're going to talk about the minimum, which we just wrote that. So it's a relative min at x equals 3/2 since h prime changes from h prime is less than 0, or you could say h prime negative, to h prime positive. And you'll notice that right here, that one looks good. This is a relative minimum. We had an x-intercept where it changed from negative to positive on the derivative graph. So that one looks good to us since we have the graph to guarantee it. And then the other guy, we have neither relative max nor a relative min at x equals 0 since h prime doesn't change signs. It went from negative to negative, so it doesn't change signs, therefore not a max or min. And again, we did it to classify both and give those justifications. So last thing we got here, guys, how about absolute max and absolute min? Show your analysis. Well, we just did this problem above. So now we know analysis for absolute max and min means make a table, x and h of x. Remember, we're not plugging into the derivative, plugging into the original. What do we include? We include any endpoints and any critical values. So I have negative infinity, 0, 3/2, and infinity. If you made your sign chart correctly, it should be those values. Okay, well, this one's a little strange. Okay, so first of all, 0 is not even in the running. Okay, it's not a relative max or min. Max or min, sorry for my writing there. Okay, so that means automatically it's not an absolute max or min. Okay, it's not even in the running. Because it wasn't a max or min, because of this right here, okay, it's not even in the running. So now we're between negative infinity, infinity, and 3/2. Okay, so h of 3/2, if we were to plug it into the original, so I'm talking about right here to h of x. Again, I'll ruin that algebra for you guys. It is equal to negative 49 over 16. All right, and what about negative infinity? Well, you guys know we can't really plug in infinity. So what we're actually going to be doing here is kind of like a little mini limit. What happens as I approach negative infinity of h of x? And same thing with infinity. What happens as I approach infinity for h of x? Okay, now remember, your function starts out with 3x to the 4th. If you guys kind of remember back to algebra 2, if it's a positive power, an even power with a positive coefficient in front, it ends up, no matter what's happening in between. The end behavior for both is positive. Or you could think plug in a really big negative number here, plug in a really big positive number, and either way, and you can see from the arrows, one more demonstration, that we're going towards infinity, both in the negative and positive end behavior. So that being said, those are not maxes or mins because infinity is not a number. Infinity is a representation of that situation, so there is no max. So you would write that. There is no max value, okay? And that's because infinity doesn't count as 1. And besides that, we didn't have any relative maximum to deal with. We did, in fact, have a relative minimum, though, and it happens to be actually the minimum value. So there is an absolute minimum at negative 49/16 at x equals 3/2. And that's what you put for your answer right here. Show your analysis. That's the table. Okay, guys. So, again, thanks for watching. Please bring in any questions. We're going to try out number 3 as one more example in class with some trig. But besides that, please make sure you have this process down. Take a look at these examples and how we went through them. And again, think about how would I do this without that graph and try to get comfortable with that sign chart and what the function would look like. All right, so thanks again for watching, and let me know if you have questions.